at CSIR-NPL.
Please welcome them with a round of applause. Now, I would request our dignitaries to come forward for lamp lighting so that we can commence with the program. Please, sir. दीप ज्योति पर ब्रह्मा दीप ज्योति जनार्दना दीपो हर्तु मे पापम संध्या दीप नमोस्तुते.
Thank you so much, sir. Now I would request Shivani to please come on stage and present our chief guest with a token of appreciation, a plant. Shivani. request Director NPL Professor Ajanta to felicitate our chief guest with a shawl. I request Shivani to present, Shalu, sorry, to present the speaker, Dr. Pancharya, with a token of appreciation, a plant. Thank you so much, sir.
Now, I would request Professor Venu Gopalachanta, Director CSIR-NPL, to kindly address the gathering. Please, sir.
Good morning. Good morning, everyone. Thank you, Gaurav and Yashika. So this is our student brigade, so taking charge of the organization. Thank you from all of us, Bashirkar ji and Pancharya ji, Director NAL and Director CV, part of the AEISS, which is one of the 8 verticals or themes in CSIR, where uh, we all know, the CSR members know that we have 8 teams, and AEIS is represented by several labs. So today's event is inauguration of the AEISS theme, uh, 1 week, 1 theme program, where we would like to reach to the students, stakeholders, including industry, possible partners, our sister labs, so that we can take our technologies to them, showcase our technologies. So now we have technology, 25 technologies are being demonstrated as part of this 3-day event. So we have 3 days. So the first day is student-scientist interaction, in addition to the exhibition area where these 25 technologies will be demonstrated. And as part of the second day, we have 7 technologies and MOUs to be 8 now, including the RDOs. So 8 MOUs or technologies will be transferred during this event. And also the third day is a panel discussion, so that we plan and think about what and how we can work together to enhance and integrate our expertise and go forward to deliver what CSR is known for. So the breadth of AEISS is really very broad. It's commendable that under the leadership of Dr. Bashirkar, it's progressing well. So we have, if you look at the technologies that are being demonstrated, we have from bioimplants, orthopedic implants, to all the way to airports head-up display units to right. So this is a very broad area where electronics and every other basic science as well as engineering expertise is involved. This shows the strength and the possibilities which exist in CSR system. Right. So these are the teams work in bigger projects where we um, work together and deliver these projects. So I welcome you all. Thanks for attending this event and making this inaugural function a success, so that we can go forward and enjoy and learn during these 3 days of event. So some of our colleagues from other labs who have come here, CIRI, CSIO, NAL, IIP, these are all here. So we welcome you all. I take this opportunity on behalf of NPL colleagues to invite you and offer our hospitality to you all. Thank you very much.
Thank you so much, Director NPL, for the information.
I just want to add that DG ma'am couldn't be here, but she conveyed her best wishes for the AEISS team OWOT events. She's busy this week, and
dais the chief guest of the program to address the gathering, Dr. Abhay Anant Pashilkar, Director, National Aerospace Laboratory. Dr. Pashilkar is an alumni of IIT Kharagpur and IISc Bangalore. He has done his PhD from IISc Bangalore in 2002 and postdoc from NTU Singapore. He has an immense contribution in the field of aeronautics, both nationally and internationally. He's been a part of National Control Law Team for Light Combat Aircraft Project at Flight Mechanics and Control Division. He has worked as Deputy Project Director for CSIR Autopilot Program from 2005 to 11 and a Group Head of Flight Simulation at FMCD-NAL. He was the task leader for multidisciplinary and multi-organizational teams that obtained clearance for LCA Tejas for wake penetration. In 2015, he provided flight dynamic model of MiG-21 aircraft simulator at Bhuj Air Force Base. In 2018, he took over as founding head of System Engineering Division, which implements the product cycle management, multidisciplinary design, craft optimization, reliability analysis, and model-based system engineering solution for aircraft programs like CSIR MK2 and Hansa of NAL. Under his guidance, NAL received the CSIR Technology Award.
Right up there, those are the labs, and they are all listed here. Of course, I am from CSIR-NPL. We are in Bangalore. So then we have NML. So everything that we do, materials is important. So we have also lots of materials laboratories. We have, for example, NML. We have Campri. We have also CGCRI Kolkata, which works in glass and ceramics. So materials form the basis for any kind of engineering that we do. So that is also reflected in this particular theme, focused on, of course, the kind of materials that are relevant to electronics, instrumentation, or aerospace. And then we have other laboratories who come in from time to time. So basically, probably I would say we have CSI is organized among various groups. So we are primarily the engineering group mostly. However, there is also a lot of interaction with the chemical side, because we also make carbon fiber, which is a strategic material. We make resin systems, we make polymers, we have ceramics. So there is some element of that. You see it from time to time, those laboratories coming in. We also have 4PI, which is very unique. It's from the it's from the Fourth Paradigm Institute, which is again in Bangalore, within NAL campus only. They deal with now progressively
artificial intelligence and machine learning. So that's another very important element. And of course, we have NPL. I see here the timekeeper of the nation. So clearly all the standards are derived from that. By law, NPL is, they have now the trademark for doing that. And all of that, what we do requires the kind of precision that is relevant to the products that we make. Similarly, on the electronics side, on the instrumentation side, we have CV in Pilani, which is working. So I'll go through quickly many of those areas which are relevant, and I'm sure the industry partners will understand. Many other things like that. So I'll quickly go through that and give you a flavor of the laboratories in this theme. And then what is our vision, or what is that as part of the theme we think is worthwhile doing together in the interest of the country. So as you can see, this is the vision statement that we have made for ourselves. This is to be a global R&D hub, delivering state-of-the-art innovative technologies, and also to secure India as a leading manufacturing hub for all of those activities: aerospace, electronics, instrumentation, and civil aircraft. Broadly, let me say here that manufacturing is a sector in India, in the Indian economy, which the government and everybody else considers to be important. It has been traditionally on the lower side, given the fact that we are now going to become the third largest, probably maybe the second largest. Let us hope that. We have examples before us which show clearly that without manufacturing, it's not possible to really be having any depth in the strategic sector, especially, whether it is civil or military. So therefore, manufacturing is very important, and all these laboratories you will find they are having certain contributions in that sector. There are certain sub-verticals within that. I have already mentioned many of them: electronics and embedded systems, and also instrumentation. There is also one related to biomedical instrumentation, for example. So the CSIO and CV represent largely that kind of work that is going on in those labs. We are from the aerospace, so civil and military aerospace. We support military aviation, and we we are the only people making indigenous aircraft in this country. That is, within CSIR, it is NAL. Of course, we have sister laboratories supporting us. There's a lot about materials, as you can see. And we have another laboratory, CMERI, in Durgapur. So typically in aerospace systems, you have like your 5 fingers, 5 disciplines. One of them is mechanical systems. So CMERI is deeply involved in that, not just for aerospace, but also for other activities. And when we look at the missions of the government of India, whether it's the UDAN scheme, I think some of you would have heard about it. We have now 100 plus airports which have been commercialized. Many of you would have traveled through those airports. There are laboratories which are working towards the Smart City initiative. Within this laboratory, of course, biomedical obviously is connected in some ways to the health mission, national health mission. And ultimately, strategic sector itself is focused on Make in India, Made in India. So Atmanirbhar Bharat is also something that is expected out of all the technologies that we develop. What we are trying to do from a business perspective, from an overall perspective, is to have what we call push-pull model. That means traditionally that we have always been pushing technology and trying to find uses for the capabilities that we have, but we are also looking for products to pull those technologies out of the labs. So in that sense, we not only do technology development as fast-track translation directly to industry, or we also do focus-based research where the TRL levels are little lower. So in this interaction, we hope to present to you today, tomorrow, in the exhibition, as well as see what are the projects currently running and what are the capabilities within the various labs. So all of our sister laboratories, they have got their cutting edge technologies or capabilities, I request you to go to that. But also we launch mission mode projects. So when there is special requirements, we launch missions which are focused towards the product. For example, we have an aerospace mission for coatings and materials, which is currently running in its third year, and many of the laboratories I mentioned, they are all part of that. There, the aim is to deliver very niche technologies, whether it is in coatings, it is in materials. So for example, brake disc kind of materials, that means they are all composites, ceramic composites, or other kinds of composites within the various laboratories. We have various kinds of coatings which are required for projection systems, for example, in aerospace and things like that. We'll see examples of that. So broadly, all of the laboratories are having the wherewithal and they are enabled to interact directly with industry. The strength of CSIR as compared to other strategic sectors like DRDO or the military is that we have the flexibility and the mechanism available to us to sign MOUs, to sign NDAs, to do transfer of technology much more easily than probably other institutions within the SMT system of India. We also have very strong industry and academia linkages where required. We invite, in fact, industries to come forward and we have, for example, done lots of hand-holding to industries. Whenever we transfer technology, we have typically very close hand-holding from our scientists. Whatever we are doing in the lab, we want it to be translated into industry, and we want the industry to succeed because in your success lies our success. So that's the kind of model that we are open to, and all CSIR laboratories are geared towards that. The support from the headquarters with regard to signing all those MOUs or getting into those MOUs or NDAs is very strong. It doesn't take much time. So I encourage all of you to exploit that and for the betterment of your industry as well as overall Indian society. So just a quick overview of the event. Today we have the inaugural event. This is the overall. We are celebrating over three places over the entire month of August. So we started off first week today, NPL, being in the capital, so we thought that would be the right place. And the focus here is on electronics, instrumentation, standards, and also we have invited lab scientists from the IIP Dehradun. So you will find all of them readily available for discussions during the exhibition. I encourage you to interact with them to better understand what they are doing. The second event we are holding in IMMT around 12 to 14. So again, request industry partners who are interested in knowing what we are doing on aerospace materials, specialist materials, to come there in large numbers. And the last event, the final valedictory event, is in NAL, which is in Bangalore, as I mentioned, from 21st to 23rd August, which will focus on the theme of primarily aerospace. So you might get to see actual aircraft as well. So that's the overall plan. And this is, I've already described this, so I'll skip that. So as I said, it's basically about interaction, B2B interactions and certain seminars. We also have, I'm sure, some students, competitions and things like that, and primarily exhibition of what we have already achieved in the form of technologies and products. So this is about NAL. So just a quick overview from the various laboratories, just in case for those who are not aware. So NAL started off primarily developing various kinds of national testing facilities. So at the bottom you have facilities which are established many years back. So that is the wind tunnel testing facilities, which both ISRO, DRDO, every vehicle that has been indigenously designed and developed in this country, which flies in the Indian space or in the atmosphere, has been tested in those facilities at NAL. And we have had now more than 60,000 blowdowns, as we call it. Chandrayaan, Mangalyaan, all of those things that you know, which are public knowledge now, they've all been tested in our facilities. We also give life extension to aircraft for the Indian Air Force. What you see there is, on the right, is a MiG-21 airframe being tested. We have simulation facilities and so on. and lots of products in form of coatings or actual materials, like I said, carbon fiber, for example. We also are in the process of making carbon brake discs, for example, and things like that. And then the other major vertical is the civil aircraft programs. So you see, this is a two-seater which has been certified. This is currently a 19-seater under design development, and this is in the future a 90-seater aircraft. So that's the kind of work that we do, and there are various divisions behind it. So I will not go through all of that. It covers all branches of aeronautics. So that's what AEISS. Then coming to CIRI itself, so they are organized among three major verticals. So you have semiconductor devices, you have vacuum electronics, and you have electronic systems. But more importantly, they work in all these diverse areas. You can see various kinds of sensors here, various systems related to what the industry is interested in. Then you have also, for example, magnetrons, LEDs is one major product line from CIRI. You also have various kinds of adulteration detection systems which are available, and then traveling wave tubes, IR detectors. So you can see all kinds of small and big devices and systems which they are doing in the various frequency ranges, IR and so on. So you can see that they can also manufacture sensors. And you will, if you interact with those scientists, you will know a little more about it. So I encourage you to do that. 4PI, as I mentioned, is again within the NAL campus. It's recently become a full-fledged laboratory, but it was there from many years. More than a decade back, it has been repurposed into Fourth Paradigm Institute, which is basically working on AI and ML. More importantly, at the current point, they provide us the high-performance computing facility for the whole of CSIR. So all the mathematical modeling and simulation people use this facility, and I think it's also available for anybody else to use, but primarily CSIR labs use it. We do all kinds of modeling, atmospheric modeling, we do aircraft. In fact, NAL is one of the biggest users. Anybody else who can utilize those facilities within the CSIR system for their own design development, whether it's chemical, biology, aeronautics, or any other systems, is welcome to use those facilities. And that is provided from remotely, you can access that. And I think within the CSIR system, this is the biggest, most high performance computing facility that's available. Coming on to CMERI, which is a Mechanical Engineering Institute of CSIR. So you can see they cover all the traditional branches of mechanical engineering, manufacturing, material processing, industrial. They also provide consultancy, mechatronics, engineering design analysis, structural and otherwise, thermal and so on. Energy and environment, they work in that, and they do a lot of work. In fact, I think the first tractor was developed by them, and now they have made an electric tractor. So they have transitioned from traditional engines, internal combustion, to more eco-friendly solutions. And this is the portfolio of products that they have. You can see, based on all of that science and engineering, they are into autonomous systems, robotics, sustainable and digital manufacturing, smart farms machines. I mentioned that they are venturing into mobility, and of course they work with us on airborne systems. And then they also provide consultancy if you are interested, and they address these sustainable development goals of the UN. They are addressing all of that. So that's their aspirational statement, which you can, I'm sure some scientists from CMER are available who can elaborate more on that. This is again under the aerospace theme. You can see some of the examples of the products which they have developed. So I encourage you to explore. I'm sure you will find in their website. So they are also into societal applications like this kind of mob control vehicles and so on, or vehicles used for cleaning, the civic infrastructure. They are also into underwater robotics, autonomous vehicles, which is itself is very challenging because the navigation is not trivial, and sometimes if the water is not clear, visibility is impaired. So you need to have some kind of inertial or other means of navigation. They also help us in aerospace by making high temperature, high pressure valves, control valves. So that is another capability. And they have developed a lot of expertise in electronic design for electrical vehicles, their own tractors and so on. Power system design, for example. CGCRI stands for Central Glass Ceramic Research, and as you can understand, ceramics is a special type of material. Glass itself is very unique and interesting material. So they work on this, and it finds application wherever high temperatures, pressures are involved, and it has very special characteristics of its own. They support not just aerospace, but also atomic energy and many other applications. Those of you who are interested in knowing more, please do get in touch with scientists there. And as you know, fiber optics today, for example, they actually have a fiber drawing facility where they can create fibers with very special properties, which for various applications, including for high power lasers. In my understanding, that's the most unique facility in the country. So any of you interested in that, please do get in touch with them. They also work on refractory traditional ceramics, for which everybody knows. Go on the YouTube, you will find so many beautiful things done with glass, various colorful things. So, they make specialist glass as well. Then we have IMMT, which is primarily metals and minerals. So the mining and minerals. That is primarily related to extraction and concentration of various kinds of minerals. They are now responsible for looking at the mineral map of the country and figuring out ways. You know very well, whether it's in electronics or instrumentation or any coatings, we need a lot of rare earths, and so therefore the first thing we need to do is find out where to get those rare earth materials, extract them, bring them in relatively pure form so that we can use them for making various devices and instruments. So it's an integral part of this theme as well. AMPRI is another laboratory involved in materials. So that is, they are working in various kinds of materials. So partly some of those are related to civil engineering, but also some of them related to automotive and potentially aerospace structures, because we use a lot of aluminum in aerospace as well. So they work on all those kinds of materials. NML has been there for a while now, and they primarily work on, they have a materials engineering division, they have applied chemistry, metal extraction, recycling, advanced materials, so primarily focused on traditional materials like steel and its various alloys. So these are the various core competencies. As you can see, lots of ferrous as well as non-ferrous materials, and how to manage the microstructures to achieve the kind of properties which are desirable for various applications. So they have the expertise in that. CSIO is another lab which is in Chandigarh. So you can see here they have branched out not just in instrumentation but also biomedical sensors. They have this Center for Sensors and Systems. They are into energy management. They are also into intelligent machines and communication systems. But most importantly, from aerospace perspective, they are into optics. So electro-optics is very key for any kind of surveillance or any kind of camera system. So they are focused on that. And those of you who are interested in knowing, they work on various coatings. They can design traditional as well as aspheric lens systems in very compact way. And they can realize that. They have machines to realize that. So they have all the facilities to make lab level prototypes for various kinds of displays. They are into holographic displays as well. Very, very useful for fighter aircraft or civil aircraft where space is always a limitation within the cockpit and so on. They also work on similar technologies for commercial application. So IIP Dehradun, so they are also associated with aerospace by virtue of many of these things. For example, we use lots of lubricants, so tribology and combustion is important for that. Most importantly, they are in biofuels. Biofuels, as you know, today is the buzzword for being more eco-friendly, whether it's ground vehicles, air vehicles, or any kind of vehicles. Sustainable aviation fuel is very important for aerospace, and it is. We expect that in future, if you have to bring down the emissions for a sustainable aerospace, both commercial and military, then we will have to go for sustainable aviation fuels, and they are at the forefront of developing those, and they are in fact commercializing the technology, and very soon within India such sustainable aviation fuels will be refined and provided. So all of that plus of course livestock processing, and as you can imagine everything to do with petroleum. They are the Indian Institute for Petroleum, and various other supporting things. NIST in Trivandrum, they focus on three major verticals: agro processing, but more importantly, they also do lots of material processing. They have a foundry for aluminum alloys of various kinds. So that is how they get connected to aerospace theme, apart from their connection to other themes of the CSIR. SIGRI is well known for electrochemistry and lithium ion, as you all very well know. Those batteries are currently the most important ones which are under development both for strategic as well as civilian application. They in fact have a pilot plant for making batteries, and the expectation is that they will transfer this technology to industry very soon. Various kinds of lithium chemistries of importance. Our own vehicles, for example, the higher energy density batteries are of great interest to space, because any vehicle that flies in air, weight is very important, because we need to have it as light as possible. So higher energy density allows us to do that. And one of the vehicles that we make, the high altitude platform system, which we recently flew for 10 hours, it's a solar powered vehicle. That requires energy densities more than double of what we traditionally have. So automotive is like 180 to 200 watt hour per kg. Our expectation is something like 500 watt hour per kg. So these are really cutting edge technologies, and when we master that, then it helps us to make more efficient, better vehicles. Of course, the chemistry and the rest of the battery management system also has to be developed. So that itself is an engineering challenge, which between the other laboratories of CSIR, I'm sure we can tackle for the future. So these are some of the gap areas which have been identified. So I'm coming to my concluding slide. Based on these gap areas, we have some dreams and aspirations as a theme, as the aerospace, electronic, instrumentation and strategic sector theme. You can see this roadmap laid out going all the way to 2030. So I can say very proudly that most of these things are either already underway or in a very, very advanced stage of planning. So let me just mention a few of them. The country, for example, needs, as I said, air transportation. We import all our aircraft, you know very well. In the recent past, India has been the maximum people who have been buying aircraft. Unfortunately, not from our own sources, but from Airbus and Boeing, the two leading aircraft manufacturers. So it is our hope and aspiration that we will catalyze the aerospace design, development and production of aircraft in this country. So the RTA is the 90-seater regional transport aircraft, which we think fits into the Indian ecosystem under the UDAN scheme. So we've already submitted last year a detailed project report. We think within our laboratories, sister laboratories with NAL, we can venture into urban air mobility, air taxis, for the last mile connectivity. Terahertz mission is already underway. In fact, I think NPL is the lead laboratory for that mission. Gallium arsenide fabrication, gallium nitride. I think that's what CIRI would like to lead that, and this is something which is in the works. And of course, in future, other things. We are already into various kinds of sensors. There are various mission mode projects running on sensors, aerospace materials, and recently we have launched indigenous mission for mechanical as well as those related to instrumentation. We have biomedical, lots of products in that area, primarily from many labs, CMERI, CSIO, and also other labs. We also make drones, so those who are interested can contact NAL for that. So these are just acronyms for the kinds of projects that we launch. FTT is Fast Track Translation, which means in 2 years we should be able to transfer all of that to industry. So those are such projects which have very high level of technology readiness, 6 and above. That means they have already achieved lab level success and it is to go into the field. Fast track translation, fast track commercialization. So you are invited to explore those things in the forthcoming couple of days. FBR NCP is a little bit lower level of technology readiness, where we are mastering the technology, we are bringing it to a level where we can take it to the next stage to FTT and so on. And so on. So there are these ambitious targets we have set for ourselves. Let us hope we realize that, in the process also realize Atmanirbhar Bharat. So thank you all for your patience, and I wish this particular event as well as the subsequent events success. I request all of you to join us in the other 2 theme venues which we have planned. You have seen the dates. So thank you.
Thank you so much, sir, for such an insightful talk. Please give him a round of applause. Now, I would request Dr. P.C. Pancharia, Director CSIR-NPL, to discuss about the impact of aerospace, electronics, instrumentation, and strategic sector. Dr. Pancharia completed his Masters in Physics, followed by MS and PhD in Instrumentation Engineering Science from Devi Ahalya University, Indore, with 23 years of research experience in the field of instrument design and development. He has 7 patents and several research papers in reputed journals to his credit. Dr. Pancharia has received several awards and accolades, including that fellowship from 2000 to 2002 at Institute of Automation, University of Bremen, Germany. The Best Paper Award at World Congress on Lateral Computing in December 2004, and the prestigious Koch Gold Awards in 2017 for developing milk adulteration detection system. He has been Chief Scientist and Group Head of Signal Analytics Group at CSIR-NPL. Currently, Dr. Pancharia is the Director of CSIR-NPL as well as the Professor at Academy of Scientific and Innovative Research. Please welcome sir with a round of applause.
Respected Dr. Abhay Pasilkar, Director CSIR-NPL, and our Team Director, Professor Venugopal, Director CSIR-NPL, all the invited guests from industry, MSME, startups, colleagues from different CSIR laboratories, students, ladies and gentlemen. The 1 week, 1 theme program, this is a part of our program which indicates our achievement in R&D in couple of years. And this is a time to celebrate our R&D achievements. At the same time, it's a time to exhibit our products or R&D outputs to our stakeholders, that is industry, MSME, startups, academia, so that the objective of the R&D which we are carrying from last few years would reach to the stakeholders. We always talk about Viksit Bharat 2047, Atmanirbhar Bharat, Self-Reliance Bharat. If you look at the name of the theme, AEISS, Aerospace, electronics, instrumentation and strategic sectors. So the theme itself indicate a different domains, and the mother of these domains is physics. And we are standing here, it's a National Institute of Physics, that is NL, which is pioneer research laboratory in the field of physics. This is an unsung hero of CSIR, where you will find that this is a NMI of India, and where the work they are doing is testing, calibration and certification, standardization. For a simple example in our daily life, if you want to get a screw or nut, then if you require 2 screws or 4 screws, we will buy a half a kg nut and screws. The reason is that we don't have standards, we don't have compliances, we don't have industrial compliances in India, and to become a Viksit Bharat, we need number of centers of NPL across India. Every district should have one testing, calibration and standardization facility across India. Then only we can be a Viksit Bharat in 2047. And NPL is doing this work, and whenever, if any industry, they want support of NPL, once you develop a product and then finally testing, calibration and standardization, you can visit NPL and get it done as per the standards. I think that Abhay covered all these R&D work which is going in different across the CSIR labs. So I don't have much to tell. I am from CSIR Siri Pilani, and electronics stands for Siri, and we are working on different electronic research areas like semiconductors, microwave technologies, devices and electronic systems. At the same time, CSIR is working on instrumentation. So if you look at these new cutting edge technologies, like we talk about quantum computing, we talk about semiconductors, artificial intelligence, IoTs, all this cutting edge technology is nowadays is become popular. These technologies were there earlier also. AI has a expert systems, started with expert systems in 60s. Quantum physics was there. This computing was earlier there. So why these technologies now become so popular? The reason behind is electronics. The advancement of electronics. Advancements of electronics means you will have a computing power, more computing power. So earlier, 3 decades ago, suppose you want to compute something, it used to take days to compute. Now you take a fraction of seconds. So because of that reason, 3G, 4G, 5G and robotics and drones also, the main key behind is electronics. So miniaturization of electronics, new devices, new materials, and Government of India also having semiconductor mission. It's a 76,000 crores project. It includes from semiconductor material to the semiconductor products. So new companies are coming, and there is a good opportunity for Indian industry too. In Siri, we have a LED technologies at par with the commercial technologies like blue LEDs, white, green, red LED, different type of LEDs. NPL has a different type of chemicals on these, like phosphor, different phosphors they have developed. NHL developed number of UAVs, drones, and all required electronics. and instrumentation. So most of these electronics developed by aerospace has a more application in strategic sector, but same time we are also working on civilian aircrafts also. So it is a wide range of applications and domains we are covering in AEISS theme. Friends, it's very simple process we have for technology transfer. So there are technologies which is ready to transfer. So you can see in exhibition that we have different technologies with different laboratories of CSIR. You can discuss, we have all CSIR labs has a business unit. You can discuss with our business head about transfer fee and what is the license fee. And it's very simple, it's not a very complicated process. There are technologies which we are working on different mission programs of Government of India and CSIR missions. It will come within the next 2-3 years. So we are also showcasing these products also. Then if you have some new ideas, so please share with our scientists and plan. You can have a MOU, you can have an NDA with these institutes so that we can jointly or collaboratively develop new products for our nation. So very simple and single window system in CSIR. So I request you all the industry personals here to discuss with our technology business development units. So you're in net that okay, we are ready to collaborate in these projects or we are ready to take technologies from different organizations. If you contact any of the business unit, any of the CSIR labs, so they will take you the right laboratories or right business unit of different CSIR laboratories. So thank you very much for visiting us, and we are grateful to you that you spare your time for this team and the CSIR products. Jai Hind.
Thank you so much, Dr. Pancharia. Now I would like to call upon the DICE, convener of the program, Dr. S.K. Dubey, to initiate the Memorandum of Understanding, MOU signing, and also to deliver a vote of thanks. Dr. Dubey. Please welcome him with a round of applause.
Good morning, everyone. As per strategic sector is concerned, this year we are going to embrace two new things. First, we are going to provide certification and traceability to RCI Research Center Imarat lab, which is having a 30-meter chamber for RCS measurement. They are going to have a measurement traceability from us. As you know that the MOU have some legalities to be approved by competent authority. So we are not signing MOU today, but this project is for a year, and afterwards that we will have a routine calibration certification for those. A part of that, the other is the International Center for Automotive Technology, Manesar. I think AGM, EMIMC is here, Rakesh Kumar ji is here. They have requested a 5-year calibration testing certification from us. Director is in principle agreed. We will proceed with these two MOUs very soon. With this, we are at the conclusion of this inaugural session, and it's my pleasure on behalf of organizing committee to extend a heartfelt gratitude to all those who have made this day possible. So first and foremost, we would like to express our sincere thanks to our chief guest, Dr. Abhay Pasilkar, who is our team director also, for honoring us with his presence and delivering a wonderful lecture. Sir, your insights and expertise have greatly enriched our understanding and have been truly inspiring to know the CSIR technologies, their expertise as well as the domain. We are also thankful to Dr. P.C. Pancharia, who has given the highlights about the AEISS and its impact. He also talked about how simple it is to have a technology from CSIR and a single window system. We would like to thank Director CSIO and Director IAP who have sent their teams. Due to their prior commitment, they could not join the program in person, but we are really thankful to them.
We are also thankful to Professor Venugopal Achanta, Director of NPL, for encouraging us and providing a platform like one week, one theme. And sir, sir, your unconditional support and prompt support has made this instrument is the success for this event. A special thanks goes to the coordinator of each lab who is present here. Suchandran Palji is there, O.P. Khatri is there, Venu is not here, he is from NAL, and one more person from CSIU, I think Dinesh Pankaj ji is there. So they keep all their technologies here so that the students from various institutions, a part of the industry who are available there, can come and enjoy and learn and have a discussion with the concerned scientists with those technological discussions. We would also like to acknowledge the administration organizing committee for their exceptional work in planning, executing this event. Your firmness efforts behind the scenes have made this gathering a success. I would like to give a special thank to our civil and engineering section. So because they have get the exhibition area ready in a very critical weather condition. Lastly, we will extend our request gratitude to the students and the NPL staff for their valuable supports and participation. I would request all of you to participate today and tomorrow and day after tomorrow event. We have this program very vibrant. Today afternoon, students will have interaction with each and everyone who will be available here. There is a quiz program for students which will happen here in the auditorium around 3:30. Apart of that, then we are going to have an industry meet tomorrow where we will have a speaker from various CSIR institutions as well as 7 to 8 industry partners. And last day, in the closing ceremony, we will have a woman in AEISS program which will be also having participants from almost all participants. With these words, thank you once again to all of you. Thanks.
Now I would request everyone to gather outside the auditorium for group photograph. And after high tea, you all are invited for inauguration of exhibition near NPL parking opposite NPL Director Bunker. Please, everyone.
यहाँ से होगी ना अब तुम्हारे पास 3 बजे स्टार्ट होगी